So in this video, we'll look at the calculation of indefinite integrals, and obviously the difficulty of this problem depends on the given function small f of x. Please recall that by definition, indefinite integral means you have to tell me the general form of the antiderivative of the small f of x, and let me list some formulas here. Please look at the first formula. For n not equal to minus 1, and I would like to find the indefinite integral for x to the power n. I claim that the formula is going to be x to the power n plus 1 divided by n plus 1, and the whole thing plus the constant c. And it's a good question to ask you why this formula must be true. So you see the fact is that if you differentiate the right-hand side, you would see that by the power rule in derivative, you would see that for the top term x to the power n plus 1, the n plus 1 as the exponent is pulled out by the power rule in differentiation, and the exponent itself is decreased by 1. And you decrease 1 from n plus 1, you'll get the power as n. And of course, the whole thing needs to be divided by another factor n plus 1. And of course, you can cancel the factor n plus 1. So you get x to the power n. And plus c is something you just have to add all the time whenever you're trying to find the indefinite integral, right? And so anyway, because I get back these functions, so we confirm that this formula must be correct. So let's look at the second formula. So the second formula is about the indefinite integral of the function e to the x. And if you recall, we have a very special formula for the exponential function e of x in differentiation. The fact is that if you differentiate this function, the derivative never changed. So it means because the derivative of e of x is not changed. So it means when you find the antiderivative, it's also not changed, right? And you just have to add c to get the general form of the antiderivative. And this formula must be correct because of the fact that, if you recall, e of x derivative is the same as e of x again. So they must be the same, and that's why this formula must be correct. And next, please look at the two formulas. I put it up here, and you can check that these two formulas must be correct because of the fact that when you differentiate sin x, the formula tells us that it is cosine x. And similarly, for the last formula, if you differentiate minus cosine x, you can see what happens. You keep the minus sign unchanged, and cosine x becomes minus sin x. When you do the derivative calculation, it means the answer is plus sin x. And these are the basic formulas, the four formulas you have. And one of the important facts is that the indefinite integral of any functions satisfy the linear property in the sense that if you have two terms inside the indefinite integral, you're trying to find the indefinite integral of that, you can split them into two smaller parts. So it's kind of like a term-by-term integration, and the constant attached to the function can be pulled out of the integral sign. These facts are already familiar to you when you first learn the differentiations, right? Because in differentiations, for example, we also allow something like if you have a function g, there's a constant d1 attached to that. If you differentiate that, we already allow the fact that the constant is pulled out and you can find the derivative of the function g of x, right? So these kind of properties are already satisfied in differentiations. So it makes a lot of sense whenever you look at the antiderivatives, which I call it the indefinite integral in a general form. It also satisfies the term-by-term integrations. And we can do some exercises here today. So please look at the current example. The current example has a function 2x squared plus 3x plus 4. We try to find the indefinite integral of that. And please note that we have already talked about the fact that the integral sign satisfies the linear properties, which means that we can look at the answer as three terms, and at the end we have to add the constant c to represent that. The general form of antiderivative contains the plus c because c does not change the derivative of the function anyway. So look at the first term. You are finding the integral of 2x squared. And based on the power rule I stated above, after pulling out the 2, you are finding the integral of x squared. And of course, based on the power rule, it's going to be x cubed over 3, right? So it means this case is 2 times x cubed over 3. And this term is similar. I can keep the constant here. You need to integrate x, and integrating x becomes x squared over 2, right? So it is a power rule, and that's why I put x squared over 2 here. And for the last term, you have to make a guess. whenever you have a constant, you are integrating a constant, it becomes 4x, right? So I can just put 4x here. And this is basically the end of this problem. So please look at the current problem here. You are asked to find the indefinite integral for the function given here. And let's look at it term by term. The last term is the easiest because you can keep the 2 there, and e of x is a special function. When you find the integral, it never changed. And plus c can be added at the end. And how about the middle term? I keep the 7 up there. And sin x becomes what? Sin x, the antiderivative is minus cosine x. So I gave you the formula earlier about that already. And we can talk about the first term. The first term, we keep the 4 there, and inside the bracket, it should be the indefinite integral of over x, right? And please recall something from the differentiations. There's a very good function such that when you differentiate that, it becomes 1 over x. This function is ln x. So it means that as a formula, the fact is that the indefinite integral of 1 over x is going to be ln x plus c, right? So which means that I can put ln x here for the function inside the first bracket. And that's basically the answer to this problem. Let's look at the current case. I'm giving you a fraction. The fraction is x minus 1 divided by x. And please notice that it would be a difficult exercise if I ask you to make a good guess such that the derivative of it is exactly the same as x minus 1 divided by x. It's not something very easy because if you recall from differentiation, there are some special rules like chain rule, product rule, quotient rule, and you're given a quotient as the answer of the function, and you need to make a guess about this. It won't be easy. It won't be easy. So let's do it in the other way. You can use some algebra to simplify the fraction. So we can split the fraction into 2 parts because we have a common denominator. And for the terms in the numerator, we can split it like this. And now we can simplify the x factor. X cancelled by x becomes 1. And the next factor becomes 1 over x. And to integrate this function, and I think you know the first term, 1 becomes x, right? So because the derivative of x is 1. So we can just write the answer like this. And for the second term, and you know the formula already, because if you differentiate ln x, it actually becomes 1 over x. So it means the answer for the second term is ln x. And we can add the plus c at the end, and it is the final answer to this problem. So let's look at the current problem for the finding the indefinite integral of the given function. And you don't have that many rules with you now, so we have to stick with the basics. You have the power rule with you for the any term x to the power something. So it would be a very good idea if you express the terms inside in terms of x to the power something. For example, the first term, 7 times what? Is 7 times x to the power minus 3, right? And the second term is minus 10 times x to the power minus 2. And the last term is plus x. And now, to find the integral of this, we can apply the power rule. The power rule says that the 7 stays there unchanged as a constant attached to a function of x. And for the first function inside the bracket, after the integration, we can apply the power rule like this. And for the next term, it's going to be the same setting. We keep the minus 10 there, and the function becomes x to the power minus 2 plus 1 divided by minus 2 plus 1 plus 6. And once again, when you integrate 6, it becomes 6x, right? And pretty much the answer to this problem. Of course, if you want, you can express it in the slightly better way. So for example, you can take some simplification like this. And if you want, you can actually express all the terms in terms of fraction to avoid the negative exponent if you want. So for example, you can actually write it like this as the final answer. So next, let's look at the current function. Are you able to solve it by using the power rule? The answer is yes, because the fact is that the square root is actually the same as the power half, right? So I can express it this way. And further, we can express the 1 over square root of x to be the exponent minus half, right? So I can write this. It means that by the power rule, I can actually do this problem quite easily. So I can use the power rule for both terms to get this. And of course, you can simplify your answer a little bit. So for example, you can write your answer like this. And now the answer is the following. 10 over 3 times x to the power 3 over 2 plus 2 times x to the power half plus c. That's the final answer to this problem. So we can look at maybe one or two more examples. And please recall that in the differentiation, there's a product rule. So the product rule is somehow a little bit special. And so for integration, please don't make the big mistake that you can do it term by term. It's definitely wrong. And for now, we don't have that many formulas with us. The only thing we can do is we can use some algebra to expand it. So to expand this, I can multiply them out, etc. So it actually becomes 6x squared 8x minus 3x minus 4. And it's an integral of 6x squared plus 5x minus 4 dx, right? And now you are asked to integrate this function. So it becomes 6 times x cubed over 3 plus 5 times x squared over 2 minus 4x plus c. And it is the final answer to this problem. You can express it this way if you want. So anyway, that's the final answer to this problem. So we look at another problem here. We have to integrate this, and once again we can distribute the x into the bracket, so we can express the exponent for the first term to be 3 over 2, because it's the same as x times square root of x, which is the same as one copy of x multiplied to half a copy of x, right? So I can add the two exponents together. Anyway, the next term is clear because it's x times 1, which is x. So anyway, we can apply the power rule directly to this problem. The second term becomes x squared over 2. I apply the power rule, and the first term becomes 5 over 2 for the exponent, divided by 5 over 2. And that's basically the answer to this problem.